Basic control concepts, open loop versus closed loop. This is Adnan Sani from Sani Enterprises. What do we mean by closed control? It is important to define precisely what this term means. In a closed loop system, the system output is the variable being controlled. Is the variable being controlled. The easiest way So, the easiest way to understand what a closed loop system does is by comparing it to an open loop system. With open loop control, the system responds to an input signal, often called the command signal, and varies the output accordingly. But the system cannot automatically correct for any outside disturbance or changes that might occur. For example, consider the control of an automobile speed. This is an example of open loop system. Acceleration, and there is output signal. The input signal to control the speed of the car is the acceleration pedal. The further the pedal is pushed down, the faster the car gives. However, there is no accurate relationship between pedal position and vehicle speed. In reality, many other things will also affect the speed of the car, such as the load the car carries, head or tail winds, travel uphill or downhill, condition of the engine. The system output vehicle speed is controlled by an input signal pedal position, but external forces or may affect the controlled output. As shown in this figure, this is the pedal, and this is the engine and the transmission, and this is external forces, variation, load, gradient, wind, resistance, etc. Output speed varies. Another example is the case of a hydraulic motor controlled by a simple throttle valve. The speed of the motor can be varied by adjusting the throttle setting. But other factors will also affect the motor speed. These factors include load pressure, system pressure, fluid pressure, leakages. Consider again the example of the car, but this time we'll outfit the car with cruise control device. Now the required speed can be set by potentiometer providing an electrical input to the system. The vehicle is also fitted with a speed sensor which provides a feedback signal that is proportional to the actual speed of the car. The cruise control device now has the ability to compare the desired speed via the input signal to the actual speed via the feedback signal, and can automatically correct any difference between the two. The signal from the speed sensor is called the feedback signal because it measures system output and feeds the information back to the system input for evaluation as shown in the figure. Now this is the feedback signal. If the car started to climb a hill, the speed would tend to drop, creating a difference between the input and feedback. This difference would be amplified by the cruise control and sent on to the engine throttle as a control signal, which would cause the throttle to open and stay open until the actual speed equals the command speed. The cruise control is an example of a closed loop system which maintains a constant vehicle speed regardless of outside forces. In control system terminology, this outside force are referred to as disturbance forces because they disturb the system. Many open loop systems are operated in a closed loop manner, but the error correction is performed by a human operator. This is normally what happens is, for example, a car that does not have a cruise control system. The driver decides the desired speed and pushes the accelerator to attain that speed. The actual speed is fed back to the driver by the speedometer. The driver then acts as the cruise control and adjusts the throttle accordingly. However, the system accuracy is affected by the ability, the experience, and the attentiveness of the human driver. A true closed loop system senses the speed output and performs the correction of any difference between input and feedback signal automatically without human intervention. The difference between input signal and feedback signal is called the error. The goal of the control system is to keep the error signal as small as possible at all times. Since the error correction occurs automatically, the system does not need to rely on the ability, senses, reaction time, or experience level of the human operator. Electro-hydraulic application of closed-loop system can be divided into three basic types: position control, velocity control, force control. A system may apply a combination of types: a hydraulic press, or example, may be position control to a certain point, then switched over to pressure control to perform the actual pressing operation. Some application may also require the control of position and velocity at the same time. Others may require sophisticated motion profiles involving very specific speeds, acceleration, and positions in a complex and repeated patterns. There are often many different ways of achieving the control's objective, but as the flexibility and accuracy requirement increase, so will the complexity and cost of the system. Therefore, it is important that a closed-loop system be chosen to meet the system demand as closely as possible. This will ensure that the specification can be met and that performance can be optimized, but at the same time ensuring that the system is not costly overkill solution. Thank you very much. This is Anajni from Sunny Enterprises. My WhatsApp number is 0092-321-312-4225-402, and the emails are adnan_sunny@yahoo.com, sunnyadnan@gmail.com. Have a lovely day. Thank you. Bye-bye.